Welcome to part 2 of graphing systems of linear equations and two variables. We're going to go ahead and just do these next two to get an idea what's going on. And once again, we're looking for the intersection point of these two lines. So we're going to go ahead and graph the first one. I guess we'll do this one in black. And I'll go ahead and solve this for y. So if we add x to both sides of this equation right here, we get rid of the x here, we get y equals x plus 5. So this is going to be a line with slope 1 and y-intercept 5. 0, 0, 5. So right here we got 0, 5, slope 1. It's going to go, and we want to look about like that. So we want to draw the lines pretty exact to make sure that we do actually see where these things intersect each other. So looking at the second one here, I'm going to go ahead and solve this for y as well. So if I subtract 2x from both sides, we get our negative 2y carries down, so we have negative 2y equals negative 2x plus 10. Divide everything by negative 2. Cancellation here, so we get y equals x minus 5. Now, this has y-intercept negative 5, so we have 0, negative 5. And this has slope 1, so it goes up 1 and over 1, so it's going to look out like this. Now, the question is, where do these two lines intersect? Well, notice this has slope 1, this has slope 1. Because the slopes are the same, these two lines are parallel. Because they have different y-intercepts, they're not the same line. So these don't touch anywhere, which tells us that this system has no solutions. No solution. Which means it's inconsistent. But because these are two different lines, we say they're independent. So in classifying the system, there's no solutions. Another way of saying that is it's inconsistent and it's independent because we have two different lines going on right here. So this next one that we're looking at is x equals 4. Now, if you recall, x equals 4 is a horizontal line with x-intercept 4, 0. So that's a vertical line. Looks about like that. Now, graphing the second one, y equals negative 5. Well, y equals negative 5 is a horizontal line that has a y-intercept at 0, negative 5. Now, that right there. So there is an intersection point to this. That is this point right here. So we want to determine what that is. And if we think about this, well, every point on the black line has an x value of 4. So this has to be 4, comma something, and everything on the red line has a y value of negative 5, so 4, negative 5 is the solution. If we plug this back in, we can only plug the x in the x here. 4 equals 4, check. Plugging in this one here, we can only plug the y in for y. Negative 5 equals negative 5. Makes a lot of sense. So because there is a solution, at least one solution, we say it's consistent with the solution 4, negative 5, the ordered pair. And because we have two different lines, this is said to be independent. So consistent and independent because we have the solution. So that's those, and we'll see you next time for a much more algebraic approach to solving these systems of linear equations.